Hello everybody, my name is Jordan. I'm with Digital Dice and Database, and here is our dice. You can see the board right there. It's embedded inside this 3D printed dice. It has a slot on top for charging that we left, and we've since super glued the lid on so that way it doesn't come off when you're rolling it. It's a C-JAL BLE Sense. It has an IMU, which is an accelerometer basically. It many times has a gyroscope attached, and it allows us to read the dice side value and then transmit that via Bluetooth to our ESP32, which is actually our central processing unit in this project. So let's hop to the code. This is the device ID that we'll be advertising, and then we add the accelerometer data as a characteristic to that device ID. And we do setup. We have some exceptions. We set the local name for the device as IMU sensor. So that's what you would see if you were using Light Blue or another app. And then we add the characteristic for the accelerometer to the device ID basically. When we begin advertising these. So it'll print this while it's waiting for connections. But once it does find something and something connects to it, it'll let you know what it's connecting to. And then it will go through this loop, and it will stay going in this as long as it's connected. So it'll read the X, Y, and Z accelerometer values, concatenate them into one string Excel data, and then it will write that value to that characteristic that's going to be read by the other device. And then it'll also keep printing it so you know what's being printed. So just to give you an idea, you can see that as you move the dice or turn it, the values change. This is what allows us to basically determine the dice side on the ESP32 is using this data. So this is our ESP32 code. We have the Wi-Fi, we have our InfluxDB connection, and then we have the same dice device ID and the characteristic that we're looking for. We have some flags that help with the project, and then some more values that also help with the project. I'll explain in a little bit. So we begin by setup. It connects to the Wi-Fi and then begins scanning via Bluetooth for a specific ID, which is what's advertised by the dice. If it finds a device with that, it sees if the name is IMU sensor. If it is, then it basically kind of skips through this and goes down here and verifies it also has the accelerometer data characteristic and begins to basically read that. So then that goes down here, read accelerometer data characteristic. And we used a buffer to split apart the X, Y, and Z again. And we keep track of what values were as they're being sent. The reason we did that is because we wanted to be able to roll it land, and only send it once. Instead of repeatedly sending the same side over and over and over and over and over again. This will actually only send it once, which allows us to do statistics on it. And then this is one of those flags, if dice is stable and significant movement detected. So that's just kind of how we do this. It creates a line protocol data, which is what InfluxDB uses. And that's created here. You have a variable, a tag, and the field key, which is the actual data you're sending, which is the dice side in our case. And then it sends that data to InfluxDB using our function. And that is using HTTP post. And it lets you know that it sent it. And this is where we determine the dice side. So we have a threshold. Basically, if it's greater, less than, you'll know which side it is on according to the rotation of the device. So let's go to InfluxDB so you can kind of see this in action. So here, 2 is the last one, so we'll put it on 5 and give it just a second and then run it. And, oh wait, here we go, 5. Yes, that's right. So instead of doing statistics on here, we actually did everything a little bit different. We didn't use Telegraph or Grafana. We actually have our data pull back from InfluxDB using a Python script that writes our data to a CSV for permanent storage, just so that way if we wanted to do statistics on 1,000 roles or 10,000 or 100,000, it may not be feasible for us to just sit here and roll the dice all day. That way we can always keep track of current data. So it writes to data.csv, and it uses the time from InfluxDB and the value of the dice from InfluxDB, and that writes that to here. So we currently have 199, and if I run this, you'll see that it starts writing. Everything in the past hour, I believe, is what it's set to, or 15 minutes. So I'll end that. And then the way we actually do data analytics, or analytics in general on our data, is we have another function or another script that reads from the CSV, uses the timestamp and the value basically, and then plots it along with counters for each value. So we actually thought that 4 would be the greatest value, and that would be because the board's here, and due to the weight of it, we thought that it would majorly land on 4 facing up, which is the side that registers. But we either didn't do enough tests, or our assumption was incorrect, or it could also be just because of the rough sides of the edges make it hard for it to roll super freely. But 4 was actually not the leading. 4 actually came in 4th place. First was 2, then 3, 6, then 4, then 5, and then 1. If you have any questions, feel free to reach out, and thank you.